I hope everyone's having a great morning. I am Mr. Ish. Thank you for joining me. We're looking here at solving a differential equation, focusing on first order differential equations. When you're talking about determining a solution of a differential equation or solving it, what exactly does that mean? You're given a differential equation, you're trying to determine what function was it for which that differential equation is true. So that's what it means. You're trying to determine a function for which that differential equation holds true. And the process by which you'll do that is you're going to manipulate the equation you're given. You have to eliminate the derivative or the derivatives that are present and leave an equation which only demonstrates a relationship between x and y. That's the gist of this technique. There is no absolute way of doing this entire procedure of solving a differential equation, but there are 4 recognized general ways of doing it, one of which is identified over here. I'm not going to talk about the other 3 because in this video we're only talking about the direct integration procedure. But the direct integration procedure, which you use to solve a differential equation or to determine a solution for a differential equation, can only be utilized in these instances where you can clearly express your differential equation in this form, where you push everything onto that side, dy or dx, or you can say y prime is equal to your function. You know what this would be, everything for which you would have the y equals format. All of this part for which your function was equal to, you can bring it right over here, and then you could do the direct integration and then determine what that function was for which that differential equation holds true. So we should look at a couple of examples over here. This by no means is a particularly difficult subject, but this technique over here is quite reliable and it's quite easy. Supposedly you have a differential equation which has this appearance. You know, you can even write it as this: y prime minus 6 is equal to 3x squared minus 6x. This represents a differential equation. We have to solve it. What function did this differential equation arise from? And remember, we're looking here at the direct integration procedures for which the differential equation can be written in this form. If you can convert your given question into that form, you can use a direct integration procedure, and that's the easiest procedure to have. Take the 6 on the other side, this minus 6, you have 3x squared minus 6x plus 6. See, we've converted it into that form right over here. dy or dx is equal to that. Now all you have to do is basically integrate this expression you have, and when you integrate it, you will get a value. That value will be your function with the constant of integration. When you're integrating this, what are you getting? You use the polynomial integration over here. You're getting a 3x cubed over 3 minus 6x squared over 2 plus 6x plus c. After you've simplified it, you know y is equal to that. You're getting x cubed minus 3x squared plus 6x plus c, and this right here is your answer. This is the function for which this differential equation is true. If you were to do the derivative on this, you should end up back over here, and you would do 3x squared minus, here you get 6x plus 6. It's exactly the same as that, and that right there would be your answer right here. The solution of this differential equation is that function right over there. And it came about simply because we were able to relate the derivative with respect to the f of x function over there, and then do a direct integration procedure. You're given a first order differential equation. Notice these are first orders because you're focusing here on dy over dx, which are synonymous with y prime. You don't have a square involved here, and you don't have a double prime. In all instances, everything over here is first order. You're given this first order differential equation. You have to find the function for which this differential equation is true. The solution of this differential equation, that is what we're doing over here. How would you do this? Well, you have to try to see if you can convert it into this form. You can try by taking that x on the other side. You'll have 5x cubed plus 5 divided by x. You can simplify this. You'll have a 5x squared plus 5 over x. You've converted into this form right over here, as you're seeing. So now just do the direct integration of that. 5x squared plus 5 over x dx. The result of this is going to be your answer for this particular question. You're going to have a 5x cubed over 3 plus 5 natural log x plus c, and that right there would be representing the function for which this differential equation is true. And it wasn't too hard, and it should be right. Let's look at this question. We have this differential equation here, first order, e to the x dy over dx is equal to 3. We have to find the solution. Given y is equal to 2 when x is equal to 0, how do you go about doing this? First focus on this part right here, then we'll worry about all of that. See if you can convert it into that form, and you can. Dy over dx is equal to 3 over e to the x. I just took this on the other side. This is equal to 3e to the minus x. I've converted into this form right over here, so you can do direct integration. 3e to the minus x dx. You know, this is not hard. You can view it as 3 integral e to the minus x dx. You know, the integral minus x right here is really e to the minus x over minus 1. You know you're going to generate that. So you'll have 3, you'll have e to the minus x over minus 1 plus c. But you can simplify this. When you simplify this, you're getting minus 3 e to the minus x plus c. All of this is equal to y. But now let's focus over here. Y is equal to 2 and x is equal to 0. If y is equal to 2, let's bring that value in. We know the function here is equal to 2 when x is equal to 0, so bring in a 0 over here. E to the power of 0 is just 1. You have a minus 3 over here. You have minus 3 plus c is equal to 2, c is equal to 5. So we've determined the constant of integration value, and we'll bring our entire answer right over here. Y is equal to, you had minus 3e to the minus x plus c, but plus c here is a 5, and that right there is going to be our final answer right over here. We've just gotten a value for c, and that value for c is 5, and we're good. We will look at this as our last question. We have this differential equation secant x dy over dx is equal to 1. It's again first order. We have to find the solution of this when y is equal to 0, when x is equal to pi over 2. Convert this into this form right here if you can, and if you can, you then do the direct integration and you get secant x. You know 1 over secant x is equal to cosine x, so that's exactly what you're doing. Then you can do the integral, the direct integration of cosine x dx, and you know that's not hard. You're going to get a sine x plus c. All of this is going to equal to y, but we have some values over there. 0 is equal to sine x here, which should be pi over 2 plus c. 0 is equal to 1 plus c, and c is equal to minus 1. And then you rewrite everything over here, this into your proper format. Answer y is equal to sine x minus 1, and this represents a function for which that is true. You can verify it to be true. If you do the derivative of this, you're going to get a dy over dx is equal to cosine x, and the minus 1 is not over there. You take this cosine x on the other side and you retain a 1 over here is equal to 1. You have a dy over dx. This is just me checking it, 1 over cosine x, which is really equal to secant x. All of this right here is equal to all of that over there. So this function is good. Our answer here is good because this is the function for which this differential equation is true. And by utilizing this direct integration procedure, you see for those instances such as this, you have a relatively easy process ahead of you for determining a solution of your differential equation. In this video, this was our primary focus, the first order solving of a differential equation for these type of cases where you can do direct integration. But that's it for this particular video. Have a great day. Thank you for watching. Bye.